I'd heard the Ryzen upgrade path offered good value, so I bought a second-hand A320M-DVS, that's an ASROCK board, in a complete PC system with a 2200, which sounded like a mature model that I could upgrade from easily. This was my first AMD since the K6 25 years ago. From a working system, upgrading one component should be easy, right? I want to shine a light on what specific components are holding back upgradability of the budget motherboard here. This kept happening to my 3600s during MemTest. Test 4 completely shut down my system. This was the fastest way for me to test the many Ryzens that Sex kept posting to me with bent pins. I honed this test to an art for RMA. Random, real-world crashes aren't reproducible. I removed myself and pop, without any prompting, the PC shut down. We all know Prime 95 tests CPU stability, but I wanted to share what it does to component temperatures. I've had one Ryzen fail CPU bound tests, small FFTs in Prime 95. It failed before that, during a game, which prompted me to torch test it. This is 30 minutes of Prime 95. Sped up 20 times. What we're looking at is the temperatures of the VRM components as the CPU is stress tested. These temperatures increase, but only to a certain point. For reasons I'll get into, not least that I kept getting bent-legged chips, I suspected the CPU. Testing the memory and controller with large FFTs shut it down before I could get any recording worth watching. Here I've zoomed, repositioned and moved a cable to get a better view. Temperatures go up until the sensor is within about 6 inches. The distance is determined by the size of the heat source. 90 degrees is nothing to worry a MOSFET. 3600 support is still credible. I prod with my finger, not believing these massive blocks are 90 degrees. Indeed, they're not. They're merely chokes. I have a hard time touching the recessed MOSFETs, which are sinking heat into the PCB. These are DEC 3906X and DEC 3908X MOSFETs. This final shot is of the actual system just at the end of the test. You can see the temperatures reducing and the actual fans in operation around the hot components. Here's how I diagnosed the failure point on the A320M-DVS motherboard. The footage on the right was recorded simultaneously with the thermal imaging shown and screen capture on the left. The angle of the footage isn't great because you can't see what I'm pinpointing with my screwdriver, but you can see the method I used to do it. I've sped up 30 minutes of footage to 5x speed. I ran MemTest with different system configurations as shown. I start with 2666 MHz RAM because it is the default the board falls back to after any failure. 2666 MHz was about peak when the A320 released, but slower than what the 2200G APU it used to run could handle. Test 4 is the pain point for the 3600. For some reason it was able to complete, in all configurations I'm going to show here. The only differences to when it would fail are the case orientation, and it was a few degrees cooler on the 5th of July when I tested. 2666 megs, 1.1 volt, fan on. We hit 80 degrees in test 4, but I let it run on because I've been happy to run 2666 day to day. It reaches 90 degrees very slowly before I concede there's no reason to torture my poor motherboard further. Most of the time I'd been seeing MemTest fail before test 5. I put this down to the bent pins on the Ryzen Sex kept sending me. It was only when they sent me this 5th one with no bent pins that I questioned my own motherboard. The 2200G was rock solid in this board. I tried another power supply. It's just the 3600 with dual channel DDR that it has a problem with. I rebooted just to repeat with the fans off this time. We'll hit 96 degrees in test 4. That's sufficiently high to illustrate my point. I actually bought this RAM new after my first 3600 arrived. It runs at 1.1 volt flawlessly. I tested it in MemTest, one stick at a time. All was well. I was ignorant of these high temperatures here. The highs are localized to a single, tiny component on the board. It's so small that the wattage produced from it, despite the high temperature, doesn't contribute to a space heating effect. I'm curious how my stability has been improved by undervolting, so I increased the voltage to 1.2 volt, leaving the fan off, and repeat. I hit 107 degrees in test 4, and it didn't stop there. You can see a photo of the area of interest in the bottom left. The big R47 PL15 is an inductor, hence the L. Inductors are basically just wire, they don't get hot. The hot chip is labelled as PU19, just on the left of the inductor as it is now orientated. If you rotate the image, you'll see several PU and PD annotations. The PD is a power diode. PD and PU are not matched pull up and pull down FETs. PU is a catch-all label for an integrated circuit. It might contain cheap, tiny FETs, or it might be a PWM driver. Could be both. Given the heat, I'd suspect the former. I reboot, increase the clock to 2933 and turn the fan on. We'll see 87 degrees in test 4. AKUK 297, it's a DIP 12, that's a dual inline package, 12 pins, with a 2.5 by 2.5mm square of plastic contained in a boundary of 4mm by 4mm. The MOSFETs, labelled on the PCB as PQ, are all either DEC 3908X or DEC 3906X. It's likely these are the PO10s, PDC 3906 and 8X. PO10s wasn't a brand I was familiar with until I searched. The FETs are good to 125 degree junction temperatures. There's a small thermal resistance, or difference, between junction and case. So 115 degrees is about the maximum we want to be observing outside the case. I repeat using 3200 MHz, the default for the 3600, and for my RAM. This will only increase temps by 4 degrees. I reboot to repeat at 2400 MHz. This figure hasn't been used in AMD marketing for many generations. The 297 runs 4 degrees, it's 5% cooler than at 2666 MHz, and memory bandwidth is reduced by just 0.3 GB per second, or 2%. Some VRMs monitor and report their temperatures to Windows. It wouldn't be unrealistic to suspect that an integrated circuit, like the AKUK 297, contains a thermistor. I have to blame something for the forced shutdowns. I'm happy to run at 2666 or 2400 MHz, but I still don't believe these are stable without a fan. The CPU contains a memory controller, but these old boards are only rated for low power chips using slow RAM. I'm kind of tempted to buy a new board, but quality VRMs cost, and I've seen the same VRMs here used on motherboards right up to the 5500. It runs perfectly with the 2200G, at all speeds, even 3200 and dual channel, which is overclocking the 2200G. When this new RAM arrived, I think I was on my third 3600, and I could test it fine one stick at a time. It's only dual channel which provoked a shutdown. I've tabulated the results of these last few tests here. I attempted to run with 3466 MHz and 1.15 volt. It was looking good, but at 96 degrees a couple of seconds into test 4 when I stopped it. Now this begs the question, what did temperatures do here with the dual channel 3200 MHz and Ryzen 3 2200 for it to be so much more stable? Days passed before I was ready to swap CPUs and test this. I'm testing again with 3200 MHz, no fan, and 1.1 volt as a control on the 3600 still installed. Not a great control because last time I had a fan cooling it, but a fan is another variable that I can do without on a given day. Fans change. Anyway, on with those Ryzen 3 2200 tests. I get this screen every time I change CPU. The TPM is an Intel thing and I try and work around it. It's very confusing if you want to attempt to test remotely or headlessly. This video has got long. I'm going to cut and accelerate the remaining tests so you can form your conclusion. The tests really aren't that interesting with everything working correctly. The screen has a green tint now. I don't know why. A bug with my capture card or BIOS is trying to use the iGPU. It's cosmetic and only temporary. One test I would like to do is time MemTest for a complete pass and see if the little extra power used by the Ryzen 5 speeds up a test pass. As I'm reluctant to burn my motherboard with whole passes, the time to test 4 will have to suffice. Speed observed by MemTest increases more with the Ryzen 3 in response to configured RAM speed. This should be taken with a pinch of salt because the time to complete 4 tests didn't decrease that much. MemTest is intended to stress test components, and time to complete isn't a widely recognised benchmark. Temperatures are far, far lower. A peak in the mid-60s is less than the working temperature of the 3600. Given its size, the small amount of extra current required by the cores and cache causes a lot of heat with nowhere to sink it to. With this all recorded now, I will update once I've fitted fans and or heat sinks for the relevant components. If it goes as well as I anticipate, then I've saved this motherboard from the dustbin of history.